Welcome to Study Loop.
In this question, we'll understand the basic concept of the optics. The question is there are two convex lenses having focal length of 10 centimeters and placed at a separation of 15 centimeters. We have to show that a light beam coming parallel to the principal axis diverges as it comes out of the lens system. In the second part, we have to find the location of the virtual image which is formed by the lens system of an object which is placed far away. And in the third part, we have to find the focal length of the equivalent lens. Right. So the beam will diverge after coming out of the two convex lens system because the image formed by the first lens lies within the focal length of the second lens because the distance between them is 15 centimeters, right? Lies within the focal length of the second lens. So therefore the beam will diverge after coming out of the two convex lens system. Now for the first convex lens, 1 by v minus 1 by u is equals to 1 by f. Since u is minus infinite and the focal length is 10 centimeters, therefore v would be equal to 10 centimeters. For the second convex lens, 1 by v dash minus 1 by u is equals to 1 by f. The value of u would be minus 15 minus 10 centimeters, which is minus 5 centimeters, because this image will act as an object for the second lens. The focal length is 10 centimeters, so we can substitute this to find the location of the final image, which is minus 10 centimeters. So the virtual image will be at 5 centimeters from the first convex lens and minus 10 centimeter from second lens. So v dash would be 5 centimeters from the first lens, in other words. Now in the third part, we have to find the equivalent focal length. The formula is 1 upon f2 minus d upon f1 f2. Here d is the distance between the two lenses. So we can substitute f1 as 10 centimeter, which is also the value of f2, and the value of the separation is 15 centimeters. So when we substitute this and solve for the focal length, we get the equivalent focal length as 20 centimeters.